Hello and welcome to IP lesson. In this lesson we will learn about ARP protocol. ARP stands for Address Resolution Protocol, and it's a method for a network device to learn dynamically MAC address of IP host to complete data link layer header. ARP send ARP request message and ARP reply message. Let's take a look at our topology here in order to understand what is ARP and how is ARP will work in our network. In our network we have one router, one switch and 4 PCs. After we build our network and configure our devices, give IP address to our PCs, PC1 want to communicate with PC3 and send data to PC3. So let's take a look at layer 2 and layer 3 information. Here we will have the source IP address, the destination IP address, source MAC address, and the destination MAC address will be unknown. So ARP is a protocol that will help PC1 to learn the destination MAC address. Let's see how that will work. When PC1 forwards the data to the router will check something called ARP cache. The ARP cache have the IP address, the MAC address, the interface, and something called aging time. In our case here, our router didn't learn yet about the MAC address of PC3. Router 1 will forward the data to the switch. Since our switch also doesn't know about PC3 MAC address, it will do ARP request and the destination MAC address will be all F, which is the broadcast address. So here the switch did a flooding, and we can simply think about the ARP request message here in our scenario is that our switch asking our devices, are you the host with the IP address 1.1.1.1? If yes, what is your MAC address? Here what will happen is that PC3 is the target host and it will reply with its own MAC address. The other PCs will discard this message since it's not meant to them. Now all the devices along the path will learn the MAC address of PC3. Our switch, our router, will save that information on the MAC address table. As you can see here, it has the IP address of PC3, the MAC address, in which interface we learn about the MAC address, and the aging time here. The aging time is 4 hours by default, and after those 4 hours, our router will delete this ARP record, and if there is another request came to PC3, our router will do the same thing again. So if there is any communication will happen again between PC1 and the PC3 before the aging time end, our PC1 will forward the data directly to PC3, and at layer 2 it will have the destination MAC address of PC3. So the switch, the router, and the PC have the ARP cache and will know about the destination MAC address after the ARP complete, the ARP request, and ARP reply. So let's do the ARP lab. In my lab here, I will use 4 PCs and 1 multi-layer switch. So let me bring the devices. So here is the 4 PCs that I will use on my lab. Now I will bring the switch. I will choose switch here, and then I will choose the 3560 switch. I have chosen that switch because this switch support routing also. It's called multi-layer switch because it can open the data on layer 2 and layer 3. I will use the auto connect to connect my devices. So let me put the IP address of the devices and change the name of PCs. I will put a note right now with the IP addresses that I will use. For PC1, we will use 1.1.1.1. Here we will use 1.1.1.2, then .3, .4, and also I will add IP address for the multi-layer switch. It will be .5. Let's open the simulation also in order to be able to see the messages. After I put the IP addresses on the devices, we need to do a small configuration in our switch. We will learn about those commands that we will put on the switch in the coming lessons. So let's open our switch, click on the CLI, and then press No. Enable conft. Let's enable the routing first by the command IP routing. After that, we will go to the interface, VLAN 1 IP address 1.1.1.5/255.255.255.0. After that, I will give IP addresses to the PCs. In order to put IP address on the PC interface, we can click on the PC, click on desktop, IP configuration, and then here I will put the IP address of this PC. The subnet mask will be 255.255.255.0, and I will repeat this process for all the PCs that I have on my lab. After I configure the IP addresses of all the PCs, so now let's test the ARP. First, I need to send a message from PC1 to PC2. So I will open PC1, click on command prompt, and do ping 1.1.1.2. Now let's play that. So the first message here is sent with the destination all F. This will be a broadcast. Our switch will forward this data to all the interfaces because it doesn't know the destination MAC address of PC2 yet. As we can see here, PC3 and the PC4 delete this message. PC2 will respond with a message to PC1. As we can see here, this response includes the MAC address of PC2. As soon as the data will arrive to PC1, right now PC1 know how to forward the data to PC2 with the destination MAC address of PC2. This is the end for this video. Thanks for watching and see you in the next one.